Hey everyone, let's go ahead and get the show started. Thanks everyone for joining. Welcome to this week's In Rhythm Lightning Talk. I am your host tonight, Austin Michael Komatz, head of mobile practices here at In Rhythm, in place for Parag, who normally hosts these lightning talks. So yeah, we have some exciting lightning talks coming up in the upcoming weeks. Reminder that our lightning talks are hosted every Thursday at 5:15 p.m. Eastern time. Each week, one of our practice area consultants share their knowledge on the newest cutting edge technologies in the industry. And this week we have Imran walking us through the question, are we advanced robots? So this is going to be a great talk. The point of the theory is, are we advanced robots? How similar are we to just a very smart machine? So yeah, I'm super excited to hear what Imran has to say about this. So without further ado, I'll hand it off to Imran. You're up.
All right, thanks, Austin. Hey guys, for those of you that have not met me yet, I'm Imran Sahil. I'm a SDT, or if you want to call it QAE engineer for In Rhythm. As part of my job, I write codes to test a program and try to find bugs and making sure things are working or not. And for this lighting talk, I have tested an In Rhythmer that work with us to verify a theory that I have had for a long time. And from the title, yeah, you already know the theory is called "Are We Advanced Robots?" And I'm going to share with you guys the test results of these findings of testing this in Rhythmer, and maybe I can help you guys form the conclusion of this theory or not. Let's see. So next slide. So everyday life, we do a lot of repeated tasks, right? We do things like brush teeth, eat food, pet a puppy if we see one. Why do we do it? And how do we make these decisions? It's sometimes it feels as if humans were something or someone has made those decisions for humans, right? It seems very natural for us. You see a puppy, we go pet it because it's cute, right? Uh, but how do these decision making works, right? Are these decisions programmed in our system? If it is programmed, can we change the program, right? The more the more I observe my day-to-day routines, things that I do repeatedly every day, and the more I find similarities with the tech products that I use every day. For example, my iPhone, my TV, my microwave, they all serve very specific functions, depending on the conditions set while using them, right? For my microwave, I put in food, set up a timer, and click start. It does its things, right? And the more I look into these tech products, the more I find similarities within myself. It seems as if sometimes I also do things because I'm programmed to do that way, and there's no way to go around it. I'm not sure what programming language my system is using, but whatever it is using, it's very effective. Uh, Sometimes I find it very challenging to change a habit, and sometimes it just feels impossible to change a habit, right? We all have habits that we try to change. Sometimes we succeed, sometimes we fail. But why is it that way, right? To share some of the habits that I've been trying to change. The first one, can I stop using social media apps? Yes, you can. I have gone through many trials of try to stop using social media apps. We all have this habit of waking up in the morning, checking our phone, looking to social media apps, and find ourselves comparing with others. It is a bad habit, if it's used that way, right? So can I stop using social media apps? Yes, I have done that. Can I stop eating sweet food? Well, since my fitness journey started 3 years ago, I have found success some weeks. Sometimes I just fail. I give in and just go insane with whenever my cravings kick in. So I don't know. Maybe I could stop eating sweet food in the future, but at the moment, it's in a limbo. I just can't make myself stop eating it completely. It's a maybe. The next one, can I stop sleeping and stay up for 24 hours? No, there's absolutely no way I can stop sleeping. It's something that my body needs. It's like this habit. This my body's operates the way it just there's no way I can change it. And why is that? You know? Okay, so to illustrate more uh, about my theory about how humans we operate similar to these tech products. I want to show you guys. I want to show you guys how robots make decisions, right? And then we'll compare it with the findings of the fellow in Rhythmer who is a human, and we'll compare their results and see how they're similar or how they are different. So this for this lighting talk, uh, I I looked into this robot that I like a lot. His name is Wally. He's a very advanced robot from the future, and he's very cute. He got a very cute face. Look at the eyes. You see him, you just want to pet him. There's a movie based on his life called Wally. It was developed by Pixar Studios. If you have not seen it, please watch it. I highly recommend it. So let's take a look at Wally's daily routine. So this is Wally's daily routine. He always reboots his system at sunrise, and then if his battery cell is low, he will go to the roof and charge his battery cell using solar panel, and then he gets to work, recycles old trash as part of his restore art plan. If you want to find out how that goes, watch the movie. And then after he's done working, he gets back to station before sunset, and then his system shuts down till the next morning, and he repeats the same cycle every day. It's like he's in a loop, right? So now that you have seen his daily routine, I kind of wanted to show you guys how the codes in his system works. And for this lighting talk, I have spent days decoding his system, and I simplified for you guys just his morning routine function, right? He has a lot, in his system, there's a lot of codes. It's too much to explain in this one small presentation. So I'm just gonna focus on the morning routine function he has. So this morning routine function in Wally's system, it takes one parameter called time. And based on the time passed into the parameter, whenever you execute that function, it will decide what to do in at that time. So let's say you pass in the time 5:59, which is morning time. Uh, so while you pass that 5:59 into the morning routine function whenever you execute it, and in Wally's function, there's a variable called sunrise, and today's sunrise is at 6 o'clock, 6 a.m., right? And then inside the function, there are some conditions. The first one is called it's a if condition. This if block will look at the time you passed when this function was executed and compare with the variable value it's stored, sunrise. If the time you passed matches with the sunrise value, then it will execute this block of codes inside the if condition, which includes reboot system, go to work field, and then return done. However, since we passed the time 5:59 a.m., this block of code will not be executed because it does not match the sunrise time. So in this case, he has another block of code. It's a else condition. So what happens if he doesn't execute this if block, he will execute what's inside this else block, right? That's his backup function block. right? So since he's not going to reboot his system in the else block, he will execute the sleep function, which will let his system stay offline for 1 more minute. And then after that minute passes, he will call the morning routine function, which is the name of the function we are inside at the moment. So in programming, when a function calls itself, we call that a recursive function. And this only way a recursive function stops, it's one of the conditions have to return something, or else it'll just keep looping. It'll just keep trying over and over again. So in our case, lucky for us, the second time we call morning routine, it'll add 1 minute to 5:59, which equals to 6 o'clock in the morning. And now during the second try, it matches with the sunrise value, and he will wake up. He will reboot his system, go to his work field, and morning routine will return done, and he can go about executing the next function in his system. And since his morning routine is over, right? Okay, so now that you have seen how Wally makes his decision, let's look at the fellow in Rhythmer who I picked for this presentation. Uh, I want to reveal his name and picture to you guys, but for privacy reasons, I cannot do that. So for simplicity, I'll just refer to him as in Rhythmer and use he as his pronoun. Okay. Uh, and use he as his pronoun. And so let's, now that we have seen how Wally makes decision, let's look into how this in Rhythmer makes his decisions in the mornings. We'll also look into his morning routine function that he executes every morning. So for our example, first we'll look into uh, uh, the first example. Morning routine falls 7:55, which means the morning routine function for this in Rhythmer is a little more complex. It takes two parameters, right? The first parameter that's set to false is day off, right? When you executing this function, you have to let the function know, is it his day off or not, right? And then the second parameter, you have to pass in the time, what time it is that this function is getting executed. Think of this as you waking up uh, and checking the time every morning and deciding, should you get up from bed and go to work yet or not, right? So this in Rhythmer, um, we'll, we will pass for our first example, we'll pass in when we're executing this morning routine function. We'll set the first parameter day off to false and time 7:55 a.m. So day off false, that means he has to go to work today. So let's see when he goes to work. Okay. So inside the morning routine functions, there's a if condition. All right. This if condition will first check, is the day off set to false, and is the time equal 8 o'clock a.m. Right? If both of the condition matches in the if block, it will execute what's inside the curly braces. You can see from line 8 to line 16. So if it's day off is set to false and 8 o'clock in the morning, then he'll wake up. His waking up involves brushing teeth, eating breakfast, put on his pants, and then go to his work desk, which is not that far from his bed, and then it will return done. The if condition will be done, right? However, since we pass day off equal false and time is 7:55, this condition do not match. So this block of code will not be executed. So what happens if that block of code doesn't exist? What does he do with his morning? So that's why there's another block of code in his morning routine function. It will check, is day off equal to true, meaning he doesn't have work today, and is the time equal 10 o'clock? If it is, then it will execute this block of code. However, since our day off is set to false, so this else if condition does not match. So we will also skip that block of code. And the third condition, if none of these conditions are matched in his program, the default condition that will be executed is sleep more. This in rhythmer gets to sleep for 1 more minute happily, and after that minute is passed, this morning routine function, which is a recursive function, as I was explaining in Wally's morning routine, it'll call itself again and add 1 more minute to it, right? Think of yourself waking up in bed, you look at the time, it's 7:55, you have to get up at 8, and you go back to sleep, right? This in rhythmer is just doing just that. He goes back to sleep for a minute, but in his case, we will have to execute this function 4 more times to reach 8 o'clock, right? On the fifth trial, the time will become 8 o'clock, right? So the morning routine function will have a parameter day off set to false and time equal 8 o'clock. I hope you guys are following what I have been explaining. I know it's a lot, but bear with me, it'll all make sense, hopefully. So the fifth try, the day off is false, time equal 8 o'clock. Both condition matches. Now this block of code will be executed on the fifth trial, right? Now this in rhythmer has to wake up and he has to go to his work desk to log into work, and then it will return done, meaning his morning routine is now complete. And in his system, now he can move on to the next function in his daily routine, which we are not going to get into. It's too much for today. So this is the full, this is what the full uh, block of code for his morning routine function looks like for this in rhythmer, and versus this is what Wally's morning routine function looks like, right? As you can see, Wally's morning routine function is very simple. He just cares if it's sunrise. If it is sunrise, he will wake up, go to work, and come back home. It's a very, very simple routine he has, not that many conditions he has to care about, right? Versus this in rhythmer, whose morning routine takes two different parameters, and based on the parameter data you pass, a value you pass, he will decide what to do, right? What to do. And as you can see, this in rhythm is far more advanced, complex, and he has to factor in multiple different data sets before he decide before he makes any decision. And he does this. uh, he compares value data sets values for throughout the day for other functions he has, like eating lunch, deciding when to eat lunch, right? When to go back to work, or when to log out of work. He has to uh, va- validate different type of data sets in his day-to-day routine before he makes decision, right? So what have we learned from all this? All right, you have seen how Wally makes decision, how this in rhythm makes decision. Well, in conclusion, actually, I cannot share the conclusion with you guys because there's lack of robot employment policy at InRhythm, and we don't want to jeopardize this InRhythmer's employment status here. We don't want him to be unemployed. So I'm not going to share the conclusion of this finding. However, I did present to you guys a lot of facts, and how the decision making works for both robots and this in rhythmer, and hopefully uh, this helps you guys form the conclusion for yourself and decide, are we advanced robots or not, right? Even if you didn't find this useful, at least you learned how recursive functions work, and recursive function and if else conditions work in programming, and that's something to go home and tell people you've learned today. if this was a waste of time for you. So that concludes my presentation. No questions, but if you have any theories, do share it with us.